Hi everyone. Welcome to this virtual tour of the Designing Participatory Futures or DARE lab at UMBC. I'm Fuad Hamidi, an assistant professor in information systems and human-centered computing and the director of the lab. I'm going to talk a little bit about our research and the tools and processes we use here in the lab. For more information, please look at our website, which is at participatoryfutures.com, and you'll find more details about our projects and also the students who are working with me in the lab. Okay, so in our lab, we generally are interested in questions of that relate to the relationship between humans and technology, especially emerging technologies such as digital fabrication, for example, 3D printing or laser cutting, and also adaptive technologies, so technologies that change in response to people activities. We use a range of research methods, equipment, and materials to pursue research questions in the lab. For example, we have a number of 3D printers. There's 3 examples here. And these are machines that can melt and layer plastic in accordance to designer specifications. They can be used to create customized devices. And specifically, we're looking at assistive technologies. These are technologies designed for people with disabilities to assist them in everyday tasks. So for example, for somebody who has difficulty using their hand to hold a pen or a spoon, we can 3D print an object like the one that I'm holding right now in front of the camera so that they can grab a spoon or another device and be able to complete a task. And as you can see, we can specifically create a mold and then scan that mold and then 3D print it into plastic so that a person can use it. Another example of this is a handle here that we have. So usually for a device that's helps with mobility, like this device that we have here, it comes with a standard handle, but some people might have difficulty with grabbing and holding this handle. And so using the method that I described, so creating a mold using clay or other material, we can make a model of their hand, and then this can be a better fit for their hand, so they can grab it easier. This mold was not designed for my hand, but the person who it was designed for will have a better fit for their specific hand. So that's kind of an example of the type of devices that we create and we study with this. And I have a few other 3D printers here. So we have some very tall ones. This is better for larger objects. And then we have others that can work with different materials. Most of the materials we use are different forms of plastic, and each have their own kind of characteristics. So mostly PLA. So you can see this spool of material that kind of goes into the 3D printer and then gets melted and attached to this surface. So that's kind of one type of prototyping activity we do here, but also we have stations for soldering. So if you want to do physical computing or other hands-on activities to experiment with interactive systems that are, for example, embedded in an object or a device, you can play around with them here. We also have a prototyping station here with different machines and devices that can be leveraged for the same purpose. So those kind of cover some of the work that we're doing here, and I want to show you a couple of other examples of objects that we can print using 3D printing. So for example, this statue of a raven was 3D printed with one of our 3D printers, but of course you see that the size of the raven is pretty large. So for example, if you look at this 3D printer, it won't fit in here. So if you look closely, and I don't know how clear it is in the video, you can see that this model was actually cut using software into smaller pieces that then could be 3D printed separately and attached together. Another example, just to kind of show the type of things that you can 3D print, is these rings. And these rings, if you look closely, they have Braille, which is the language that people who have visual impairments can learn to read by just touching. So if you read them, you can, there's some messages that are embedded into these rings. So these are some examples of devices that you can 3D print, and both to kind of show the capabilities of 3D printing and also try them with people who might actually benefit from them by creating their own assistive technologies. Another type of assistive technology that we experiment with are devices for people who have difficulty with communication. So in this table, I have a series of prototypes. So prototypes mean examples or trials of a technology that is created to test whether a concept is viable or to test a research hypothesis. So it's not a complete product, it's different from a product, but it can be a step towards a product. So here I have a device called the TalkBox, and it's a very simple device. And the way it works is that it has some embedded Raspberry Pi computer and an audio device. And essentially, when you press a button, I haven't powered it up, I'm just gonna describe what it does. It can play any audio sound that you want. Now you might ask, like, why would we need such a device? And if you imagine somebody who has a severe disability, so I have a photo of one of the users of this device here, and she's a child who has cerebral palsy and she can't use her hand. So if you look closely at the photo, there's some difficulty with using her hand in fine motor movement. She can still use this device to make music. So for example, if you load audio sounds into this, she can use that, or she can use it to communicate. So, and the reason that we're experimenting with this device, and I have a few versions of it, for example, made with clear plastic or made with just two options and kind of buttons that are not separate from images but connected with images. But the reason that we wanted to experiment with this is that sometimes commercial devices are not well suited to the needs of some people with disabilities, and therefore we need to be able to explore different variations of this. And other variations, you see some containers that are 3D printed here. These are containers for electronics that it's also a Raspberry Pi, a smaller version of a Raspberry Pi. So usually a Raspberry Pi looks like almost the size of this board. This one has a touch board also attached on top of it, but this is essentially what it looks like. So not a very large device, but the Raspberry Pi Zero is one that kind of is much smaller and much cheaper. It's about $5 cost than this one, but it can be still a computer, so you can embed it into objects. And in this case, what we were doing is we were embedding a Raspberry Pi Zero into this enclosure, and then it has a sensor that can sense RFID tags. So these are tags that have electronics embedded in them. They're like a credit card, and it can play back any audio. So you can imagine the case where, for example, you might have a child with disabilities and they want to play their own music, but they have difficulties with that. So they can use this device to do some of that work. Other types of projects that we do here involve wearable technology. So I don't know how easy it is to see here, but we have a hat here that's augmented with LED lights, very bright lights. And in this session, there's a therapist that is using them to help soothe a child with brain damage. So these type of technologies can also be produced and tried out in the lab. In addition to producing and working with materials, we also conduct a lot of different interviews. So you can see here, some of my students have written a lot of sticky notes with text that is talking about the project that they did. So for example, they might be writing their observations or some pieces of text that are related to interviews, and we look at them very closely to understand what are people's perceptions towards different technologies that we show them. So that's another strand of our research. So hopefully that provides a bit of an overview of the type of projects that we do in the lab. There's other ones that are involved in and kind of take place in the city, in Baltimore City, not necessarily on campus. And these include working with equity-based approaches to educational experiences for youth. So, for example, in after-school programs or in community labs or maker spaces in the city, we work with organizations that provide these programming for youth, and we look to see how they can be more aligned with youth's interests and concerns in order to be more engaging. So that's another direction that we've been working on. Another example that I just very briefly mentioned is about internet connectivity. So as you know, during COVID-19, there was a lot of difficulties with attending events or school or different activities in person, and so people used a lot of online services for these type of activities. However, in a lot of places, including Baltimore, not everybody has good internet connectivity. They might just have internet on their phone, or they might have internet connectivity but it doesn't have a lot of bandwidth. So for example, if you're in a house with 5 other people, you're trying to see your teacher, get on Zoom, you might not be able to because of connectivity. And we were looking at how can we provide infrastructure, so for example antennas or other technologies that can provide affordable internet connectivity to as many people as possible. That's another project that I did in collaboration with a couple of organizations in Baltimore City, Project Waves and the Digital Harbor Foundation. And the equity-based research is also with Digital Harbor Foundation. These are organizations that are doing really interesting work in the city. So if you're interested in understanding more, feel free to either check our website or send me an email. My email is my name, Fuad Hamidi, at umbc.edu. I'm sure that the tour organizers can also share that with you if you had more questions. But yeah, thank you so much for your time and interest, and I look forward to answering any questions. Thank you.